My dear student, colleagues, and all the viewers who are watching this program live from Facebook page and the YouTube channel, I would like to welcome you all to our International Physics webinar, and I'm happy to share with you all that today it's our 65th International Physics webinar. So, good morning to all, and I hope you are well and safe from Corona pandemic. So, all we know, we are staying in a Corona pandemic situation. So, all the institutions have been shut down, including university since March 2020. So, we cannot continue our normal academic program inside the campus. So, we have to start our online program. Our Department of Physics, Pabna University of Science and Technology, has already started its online program, including online classes and online International Physics webinar. So the main aim of our of this International Physics webinar is to motivate and encourage our students in this Corona pandemic situation. So we have to adjust with this new normal situation, and we are trying to adjust with this new normal situation. And today it's a very important day for our department. Today, I'd like to welcome you all to a joint session between the Department of Physics, Pabna University of Science and Technology, and the School of Natural Science and Engineering, National Institute of Advanced Studies, Bengaluru, India, in basic research in physics. And we have with us here today Dr. Dinesh Kumar Srivastava. He is currently working as a Homi Bhabha Chair Professor, School of Natural Science and Engineering, National Institute of Advanced Studies, Bengaluru, India, and former Director and Distinguished Scientist, Variable Energy Cyclotron Center, Kolkata, connecting from us from India, and he has already connected with us. So I'd like to welcome our speaker. Sir.
Thank you.
Good morning, sir.
And good morning, and thank you for inviting me.
Yeah, it's my pleasure, sir, and thank you for accepting our invitation, sir. So we are very happy to host you in our International Physics webinar. So for those who are new, I'd like to inform that we have divided our webinar into three parts. First, we'd like to introduce our speaker with all of you, and then our speaker will deliver his speech. And at the end, we have a time. In that time, anybody can join with us. So I think you have already come to know the title of our today's International Physics webinar. So the title is "Why Should One Do Basic Research?" And the speaker is Dr. Dinesh Kumar Srivastava, sir. He is currently working as a Homi Bhabha Chair Professor at the School of Natural Science and Engineering, National Institute of Advanced Studies, Bengaluru, India. And he is also is a former Director and Distinguished Scientist at the Variable Energy Cyclotron Center, Kolkata, India. You can see his educational background. So you can see he has completed his schooling from Uttar Pradesh, and also his intermediate from Uttar Pradesh with first division, and bachelor degree in science from Uttar Pradesh University of Allahabad, and his training in physics at the Bhabha Atomic Research Center, Bombay, and his PhD from the University of Bombay. And his professional career, you can see he has a lot of career, including different position in scientific officer and other position too. So he was also a head of the theoretical physics division at the Variable Energy Cyclotron Center, and also director at the Variable Center Cyclotron Center from 2012 to 2016, and also Raja Raman Fellow, Variable Energy Cyclotron Center. So we can see his research interest, present research interest, electromagnetic probes of quark-gluon plasma, relativistic hydrodynamics, and you can see his other research interests too. And previously, his earlier research interest, break up light nuclei, elastic and inelastic scattering of light ions, saturating properties of nuclear force, microscopic optical model potential. So scholarship and awards, he got the National Merit Scholarship in the time of 1966 to 1970, and also national and international recognition. So fellow National Academy of Science and fellow National Academy of Science, also elected as the President of Indian Physical Society, DAE Group Achievement Awards, DAE Group Achievement Awards in 2013. Sir C.V. Raman Lecture of DAE, BRNS, in Indian Physics Association for 2014, and also other. And his international recognition, Outstanding Referee Awards of American Physical Society in 2009, and also member of editorial board of Physical Review C, and the member editorial board of Pramana Journal of Physics, and also member editorial board of Scientific Reports. We can see his professional responsibility and engagement, and visiting professor. So he visited a lot of places, a lot of countries as a visiting professor. You can see the list, and we can see his Google Scholar ID, and we can see his citation number is more than 5,000. So this is his Inspire Help ID. So thanks all for all of your patience. So now it's time to go to our speaker. So thanks, sir, for accepting our invitation. I'd like to say thanks on the behalf of Department of Physics, Pabna University of Science and Technology. And it's my pleasure and privilege, sir, and honor to host you in our International Physics webinar. So it's your time, sir. You can start your session.
Okay. Can you see the full slide? Pretam?
Yeah, we can see. We can see.
The full slide, full view.
Yeah.
Okay. So, good morning, Pretam. It was really nice of you to invite me. We planned several times to come to Bangladesh, where we have some very good associations with Professor Samser Ali, who is close personal family friend, who used to come to our house in Calcutta. Professor Abdul Moin Khan and his wife, Roxana Khodkar. They are very close person. Siddiq from Dhaka University. They were all visitors to our house. I'm still in touch with Professor Abdul Moin Khan, and we exchange greetings from time to time. And I was hoping that I will be able to meet all of you in person, but I'm quite sure that when we are recovered from this, Pretam will find some who's to invite us.
Hopefully, sir, we will invite you in my university, sir. Thank you.
Thank you. We look forward to being there and having a good Alice meal. Okay. So let us start. Why should we do basic research? This talk actually arose because once I was making a presentation about our activity at the Cyclotron Center, and we had done some very nice work just then on quark plasma, which was being internationally acclaimed. And I was making this presentation to members of parliament. And one of them said, "Oh, all those things are fine, this basic research in quark plasma, etc. But tell me, what does it do for common people?" And I realized that people have a kind of feeling that basic research is useless. So I took time off and studied a lot and prepared a lecture, which I keep giving from time to time and keep augmenting it from time to time, keep changing things according to the place to tell you how basic research is so very important and how it has changed our world forever. So before that, let us see what is research. On the right hand side, you can see there is a statue of a researcher holding the torch of knowledge at the Congress Library in Washington. So what is research? Research is derived from research, and it means to seek out with care. Research harnesses curiosity to search for knowledge, to establish novel facts, to solve new or existing problems, to prove new ideas, or to discover new theories. It results in discovering, interpreting, and developing methods and systems of advancements of human knowledge and understanding of nature. Okay? Please don't forget that basic research is the highest form of human activity. During the lecture, we shall tell you about joy of doing basic research and how it has changed our lives. I'll tell you that our life as humans on the planet Earth is a privilege. I'll tell you that we are made of dust of stars. Stars have exploded, died, and the dust from the stars has accumulated, formed a planet, and we are born out of this dust. And I would try to convince you that let us not lose our sleep over applications. Applications will automatically come. And it will happen because either our research will give rise to new technologies, or in order to make those studies, we will have to develop new technologies, which are always useful. Let me remind you that every atom of the nitrogen in your DNA, the calcium in your teeth, the iron in your blood, and the carbon in your bread was made in the interior of collapsing stars. We are made of stars. We are made of dust of stars. And as this great Bangla poet, Gajendra Lal wrote, किसेर लज्जा, किसेर दुखो, किसेर दैन्य, किसेर लज्जा, किसेर मेस. Why should we have any kind of feeling of inferiority because we are so great? Okay. Let us also remember that Earth is a very special planet because our sun is a long-lived and stable star. Its temperature has not changed substantially over the last several billion years, and it is not likely to change for coming several billion years. Earth is at an ideal distance from the sun. If it were closer to the sun, it would have been too hot. If it were away from the sun, it would have been too cold. Our Earth has atmosphere, which has oxygen, and it has water. Because, because of the gravity, it has atmosphere. So life forms at the interface of earth, water, and air with energy supplied from the sun. Yeah. There was asteroid impact created the moon, as you can see on the right hand side. Asteroid came and hit the earth, and then it just started rotating, and this gave rise to a moon. Now, the moon did something very interesting. First of all, because of the impact, the earth started rotating on its axis. If the earth were not rotating on its axis, then only one side of the earth would have the sun and the other side would have never come in the sun. That would have made one side very hot and the other side very cold, and you would not have had light. And because of the moon, as you must have read in high school or even junior high school, we have high tides and low tides. It has led to tides which maximize the interface between air and earth, helping formation of of life. And then about 65 million years ago, there was another asteroid impact which killed all the dinosaurs. And then mammals like us were born. Let us never recall words of Shakespeare. What a piece of work is a man, how noble in reason, how infinite in faculty, in form and moving, how expression admirable, in action, how like an angel, in apprehension, how like God, the beauty of the world, the paragon of animals. Another Hindi poet sang, the birds are beautiful, flowers are beautiful, but humans, you are the most beautiful. Look, Let's remember once again that we are Homo sapiens, which means we are wise humans or knowing humans. We have a capacity, we have a highly developed brain. Our brain is capable of reasoning, language, introspection, and problem solving. Your erect body carriage frees your hands for manipulating objects and using tools. You have a capacity of self awareness, rationality, and sapience. Our language helps us in self expression, exchange of ideas, and with writing, it passes the knowledge to next generation, several generations down the line. Yeah. And if after all this you are still not convinced, I'll request you to close your eyes for a minute and imagine a world where you have no fire, you have no levers, you have no engines, you have no electricity, you have no cures for smallpox, cholera, typhoid, malaria, plague, dysentery, polio, tuberculosis. In nature, you will find villages after villages used to be completely devastated by attacks of smallpox or cholera. My grandmother lost her brothers in one day, one single day, aged from 15 to 25 due to cholera. My nani, my maternal grandmother, she lost six of her brothers to something as severe, as simple as dysentery. And they were still very young, just 1 or 2 years old. Only now we have eradicated polio. All these things were possible because people engaged in basic research. And for this, we just need to observe and we just be curious to try to understand as to how things are progressing. Give you one example. Archimedes' screw. It was originally invented to drain water from the hold of a ship. Earlier, people used to just use buckets to throw water from ships. Yeah, and then it was used much later to reclaim land from below the sea level in Netherlands. Recently, it was used to stabilize the Leaning Tower of Pisa by draining the water-saturated soil near its base. But that is not all. The total area of Netherlands is 41,453 square kilometers. Out of that, about 8,000 square kilometers were recovered from the sea. This is Sundarban. A large part of Sundarban is in Bangladesh. Sundarban is very average height above the sea level is just about 0 to 10 meters. I just read that your Pabna has an elevation of just about 16 meters or so. It has area of about 10,000 kilometers. And I tell you, as the sea level rises, Sundarban will start drowning, making thousands and thousands of people homeless. And I have a feeling, I may be wrong, but I have a feeling that people will use this Archimedes will make walls around Sundarbans or high level bunds around Sundarbans and use this Archimedes screw to drain it. Watermill, another example from our daily life. I come from a village. Yeah. In the morning, I used to wake up to the sound of my grandmother grinding corn for chapatis to be made. But way back, more than 2000 years ago, the Greeks invented watermill. And when a poet, Antipater of Thessalonica, saw this, he was very excited and he wrote a poem, which is still quoted by so many people. And it said, "Hold back your hand from the mill, you grinding girls, even if the cockcrow heralds the dawn, sleep on." Then he goes on to say that if we learn to feast toil free on the fruits of the earth, we taste again the golden age. Let's come to more modern times. Galileo Galilei, he went to a church and there was this lamp. And he saw that this lamp was moving from one side to the other side. And he got a feeling that it was taking around the same amount of time in going from one end to the other end. He used his pulse to figure out that yes, that was true. Now, why should I tell you? First thing is that the simple harmonic motion is one of the most important things you study in physics. Second thing is that this observation helped him make first accurate watches. And why is that important? Because watches are important, accurate watches are important to make very accurate maps of the world. Because we know that local time changes by 4 minutes for every change of 1 degree in longitude. So if you know the local time and compare to some place, you can immediately tell what is your longitude. Yeah. Earlier, this was not available, and people used to have very inaccurate maps. Gregor Mundell was a priest. He wanted to be a teacher of physics, but he taught very badly. So, students did not like his teaching, and he started doing research. And during research, he developed this theory of dominant and recessive genes, of inheritance of genes. So if you have a dominant gene and a recessive gene, the red one is dominant and recessive is white, then in the second generation, you will have dominant gene, all of them, and in the next generation, you will have their distribution in the ratio 3:1. Now you see in our houses, whenever a child is born, people often tell, "Oh, the child is looking like grandfather or the grandmother." But we never did go beyond this. And here is this man, he studied this in great detail, and by crossing peas, he crossed a tall peas with short ones, the ones which had rounded seeds with the wrinkled seeds, the ones with yellow seed color, with green seed color, the ones with seed coat color being green and white, ones with the pot shape like inflated and constricted, ones with pot colors of green and yellow, ones with flower positions as axial and terminal, and did crossed all these plants and observed them. And then he analyzed more than 30,000 plants to give this theory of 3:1 ratio, statistical distribution of inheritance of genes. Yeah. Charles Darwin, who discovered theory of evolution, that we have all one common ancestor. He collected data. For this, you have to collect data. And what he did, he he joined one ship, HMS Beagle, as the botanist or naturalist, as they were called those days. They started from Plymouth to Africa, to Bahia, to Rio de Janeiro, and of course Cape Verde, to Bahia, to Rio de Janeiro, to Montevideo, to Falklands, Valaparios, and then Galapagos, came back to New Zealand, to Sydney, to Harvard, to King George and Mauritius, Cape Town, and again to Bahia to collect some of the samples which they had deposited and returned to Plymouth. Okay. And during this process, he collected huge sample of birds and turtles and fossils and flowers and animals and plants and humans and fish and ants and bugs and whatnot to arrive at his revolutionary theory. Now there are indications that Alexander von Humboldt, who had earlier followed a similar route and explored deep into Latin America. In fact, in Latin America, there is still a trail called Humboldt Trail, which he had taken. He was close to this view, but he was perhaps daunted by it as he was too religious. Abraham Ortelius was a cartographer. He used to make maps. And while making maps, he noticed that Africa and America, Latin America and Africa, they almost fitted exactly maps. So he made a suggestion that perhaps Americas were torn away from Europe and Africa by earthquakes and floods, and went on to say some things like this, that vestigial rupture revealed themselves if someone brings forward a map of the world and considers carefully the course of the three continents. Yeah. And in fact, now it is known that all these continents were joined at one end called Gondwana land at millions of years ago. And then, because of tectonic plate movement, they all moved away and drifted apart. And how was it confirmed? It was confirmed by noticing that the fossils in South America, Africa, India, Antarctica, and Australia were identical. This is one particular fossil. It is of Glossopteris fossil leaves, which were found in the Gondwana district in India, and which confirmed this thing, and that is why it was given the name Gondwana land, which is forest of Gonds, Gondwan. Which was also given this name by Edward Suez. You know this story of Newton discovering this, and this is often told that because he was sitting under the apple, and no, yes, but he had a prepared mind. He had a well-prepared mind, and only when you have a well-prepared mind, you can recognize a breakthrough. Now, it is estimated that more than 22 million Africans were sold into slavery, about half of them dying on the way. The indenture system was an ongoing system of indenture, a form of debt bondage, which took about 35 lakh of Indians to various colonies of European powers to provide labor for the mainly sugar plantations. It started from the end of slavery in 1833 and continued until 1920. Let me also tell you that the Slavery Abolition Act 1833, which freed African Americans in USA and in America, it had a special clause which permitted slavery in India and enslavement of Indians for colonial markets operated by East India Company. These are some pictures of Indians and African slaves taken to various places. And if you can find, maybe there is a Bangla translation of this wonderful book by Amman Unas called Lal Pasina, the Red Sweat. about struggle of Indians in Mauritius. You know this story of James Watt watching the boiling kettle and then going on to make one of his first steam engines. There were many others also who made. But I'm telling this because you know this story. And this steam engine ultimately really revolutionized. This was the beginning of the Industrial Revolution. And with the Industrial Revolution, for the first time in history, the living standards of the masses of ordinary people underwent an unprecedented and sustained growth during the Industrial Revolution. I might tell you that a gentleman called Dennis Poppen near University of Marburg in Germany, who invented steam engine. He wanted to take it to England to show to the people that yes, I have also made steam engine and it works very well. But the peasants there, they destroyed it because they thought that it was work of the Satan. Okay. The Industrial Revolution is also believed to have led to development of scientific temper in the West, which is still missing on a large scale in India or in the East. Michael Faraday's, the story is well known, and during science studies, you must be reading about Faraday's laws of induction, electrolysis, lines of force, the discovered benzene, etc., etc. He asked for a small grant to British Chancellor of Exchequer, which corresponds to the finance minister. He asked for a small grant, and that fellow said, "No, what is the use of it? Studying electricity." And he told him that one day, sir, you may be able to tax it. Now that makes finance ministers very interested, and he got the funding. And we know what electricity did. The motor and dynamo, electric motor and electric dynamo, both came out of these studies. Let me come back to India. Indigo, we all use indigo, right? Neil, to give shining, brilliant color to our dresses. It used to be grown in India and also in part of Bangladesh and India, UP and Bihar, Odisha, in a big way. These British rulers of that time, they would come and forcibly give loans to our workers, our farmers, asking them to grow indigo. Now, indigo has this peculiar problem that once you grow it, there is some kind of toxic juice dipped from the plants, and after that, nothing grows in the field, and therefore people were very worried. They would not take. And these fellows used to have called a whip called Shamchand, and the Bada Sahib will sit there, and if the farmer said, "No, I will not take your loan to grow indigo," the Gora Sahib will say, "Bhai mera Shyamchand ko bulao to," and he will use that whip. It used to be made from hide of buffalo and used to have steel knobs studded into it. It was the extreme suffering of our people. These studies, these atrocities were eliminated as in 1865, a German chemist, Adolf von Baer, started working on synthesis of indigo. He described his first synthesis in 1878 and second synthesis in 1880. And once chemically synthesized indigo was available, the suffering of our masses came to an end. It did not come to an end because our British masters became very dayawan. Okay? It came to an end because there was a basic research done to produce indigo. Rubber, we all know. Now, this gentleman, King Leopold II of Belgium, he was the sole owner of Congo Free State. He initiated brutal exploitation of Congo, first for ivory and then for rubber. People were forced to strap rubber and their hands used to be chopped off, like the hands of our weavers used to be chopped off by people of East India Company. Buffalo used to chop off the hands of people if they failed to meet quota. And it caused death of up to 15 million persons. The introduction of rubber cultivation in Malaysia, India, and Sri Lanka, perhaps by stealing seeds from Brazil, and invention of, most importantly, invention of artificial rubber in 1910 put an end to this exploitation. We all love to eat cheese. I don't know whether in Bangladesh you have Burger King and you have cheeseburger, but cheese is a very popular thing, and it was discovered when a bag made from the stomach of unweaned calf, which means a calf which was still taking milk from its cows and had not started eating grass. It was used to store milk. A large number of such calves used to be slaughtered for the enzyme called rennet, which is found in their stomach, which curdles and coagulates milk. Now, most of this enzyme is produced using recombinant DNA technology. So, if you do basic research, you can avoid unnecessary slaughter. Famines in India killed 60 to 80,000, 60 to 80 million people in 18th, 19th, early 20th century. This great Madras famine in 1876-78. Same, Great Madras famine in 1876-78. This Bengal famine, of which we all know, 1943. People dying. These are some sketches of Bengal famine by General Abedin Sahab. And if you find that, you should try to get this book, Churchill's Secretary, Matsuri Mukherjee, for studies about these. Okay. Green Revolution was started by Ernest Borlaug. He supplied seeds to India and Pakistan in 65 for wheat, which he had developed. And the wheat production in India and Pakistan went up by a factor of almost 5. Our population has gone up much more than it was at that time. And at that time, we were not having enough food. And now, even though the population has increased, a lot of food is produced, and we are having surplus food. And for this, what he did was to first cross rust-resistant wheat with the high-yielding one, and then with semi-dwarf wheat to get Pictic 62 and Penjamo 62 wheat. Now, it is estimated that more than 1 billion people, which means 100 crore people, 100 koti people were saved from starvation. Now, if this wheat was not discovered, people would have cut down forest after forest to show more wheat or more food, grow more food. And young people today know what does forest mean, how a devastation of forest can devastate the world. And this was possible because he had a very good understanding of the basics of plant pathology. He was doing research on that. The same method is also used to produce better quality of rice, which leads to a lot more production. So basic research has solved the problem of hunger of the world. Distribution is a separate issue. I'm not going to talk about. This gentleman, Edward Jenner, he noticed that milk maidens milkmaids were not getting smallpox because they were exposed to cowpox virus and did not catch the smallpox. So he discovered a vaccine for smallpox, and but it was and he discovered vaccine. It was not used extensively for almost 100 years, but now of course smallpox is eliminated from the world. Yeah. It used to cause about 80% of people who used to turn blind because of smallpox.
Dear student and all the viewers, so we are sorry that we have disconnected with our speaker, and I think we'll connect it with our speaker very soon. So stay with us. my dear students, colleagues, and all the viewers. So we are very sorry that we cannot connect it with our speaker. So we have to stop this live session now, and we will connect it again uh, when we connect it with our speaker. So bye for now, and hopefully in very soon we'll go live session